Hello everyone. In this video, we are going to talk about position vectors and displacement vectors. Position and displacement vectors. To describe the position of an object moving in a plane, plane means a two-dimensional situation. So we need two axes, say x and y, to represent its motion, to represent the motion of an object. That is, to represent the motion of an object in a plane, we need two axes. It can be x and y or y and z or z and x. Okay, whatever it is, we need anyway two axes to represent the motion of that object. And we need a reference point about which we describe the position of that object at different times. So let that reference point be the origin when the two axes or where the two axes x and y coincides. Alright, now you see here we have x and y axis and this is the origin. We are talking about the motion of an object in a plane. So in the xy plane, that is why I have drawn the x and y axis here, and this origin is the reference point about which we are going to talk about the or about which we are going to describe the position of that object. Okay, so consider an object which is moving along this plane in the xy plane. Okay, you can consider that object as an ant moving on the surface of this paper. Okay, that is, it is moving on the, it is moving in a plane now. Okay, so let this point P be the position of the object at some time t. Okay, let this point P be the position of an object at some time t. Okay, and if we join actually these 2 points, okay, at time t, P is the position of that object. Okay, that is, that object has reached somewhere here at this point P at a particular time t. Alright, now if we join these 2 points O and P by a straight line, then this OP, no, or if I am putting an arrow mark here, this vector OP, no, vector OP, this is actually the position vector of this object that we are considering here moving in the plane. So position vector of the object at time t. Okay, so it is actually taken from the origin to the point P. Okay, the arrow mark shows the direction. That is, the arrow mark shows the direction means the position vector of that object is taken from the origin to that point of that object at that particular time t. Okay, this position vector, it is actually represented by a symbol vector r. Alright, so this position vector that can be represented, vector OP can be represented as vector r. Alright, now you just imagine after some time the object is moving in this plane, in the xy plane. So after some time the object has reached at this particular point. So I am taking this point as P dash. At another particular time I am taking that time as T dash. So object was at this point P at a particular time t, and after some time the object has reached here at this point. That point is named as P dash. Okay, in another time. So that object has reached here at this particular time t dash. Alright, now if we join these 2 points, that is O and P dash, by a straight line, then I am marking one arrow mark here. Then this vector OP dash, it actually gives us the position vector of this object at a time t dash. Okay, that position vector, it is actually represented by vector r dash. Okay, so position vector of this object at time t dash is vector OP dash. Vector OP dash is represented by vector r dash. Usually we use vector r to represent the position vector. So here we have 2 position vectors now. So to distinguish these 2, we have taken one as vector r, another one as vector r dash. That's all. Alright, now the length of this vector, no, that actually represents the magnitude of the vector. Okay, the length of this vector from here to here, this actually represents the magnitude of this vector, and the direction is in the its direction is the direction in which P lies as seen from the origin O. Okay, this arrow marks actually gives us the direction in which the point P lies as it is seen from this point O. Okay, now suppose that the object is here at this point P initially and it moves towards P dash and reaches here at this point after some time. So P is the initial position of the object and P dash is the final position of the object. Alright, now if we join these 2 points P and P dash by a straight line, we will get a straight line here, which is the displacement of this object, because final position minus initial position is the displacement of an object. No. And what about its direction? It is directed from the initial position to the final position. So displacement, it is actually a vector quantity which is directed from the initial position to the final position. So arrow mark will be like this. Okay, it is directed from the initial position to the final position. The displacement of the object that doesn't depend on the actual path taken by the object between the 2 positions. For example, you see this figure. Let an object travels through this path PDQ, okay, from the point P to the point Q. Okay, initially it starts its motion from the point P, then it moves along this path to reach this point Q, where Q is the final position of that object. So here, the displacement vector will be what? The displacement is actually the straight line distance between the initial and final position now. So we just want to draw a straight line from this initial position P to the final position Q. Okay, then we want to mark an arrow mark here. This arrow mark should be directed from the initial position to the final position, because that is the direction of displacement. So, here the displacement vector is what? Vector PQ. Right, here the displacement vector is vector PQ. Alright, now similarly, if the object travels through this path, okay, if that object travels through this particular path, for example, let it be PBQ. Okay, it starts its motion from the point P. It ends its motion at the point Q, but it is choosing another way to reach the point Q. Okay, that way is PBQ. So, if the object travels through this path PBQ to reach the point Q from the point P, so here also what about the displacement vector? It will be vector PQ, no? Because that object has taken this particular path for its motion to reach the point Q. But anyway, it is the initial position and it is the final position of that object. Right. So, displacement vector is the vector which is directed from the initial position to the final position. It is a straight line one. Okay. So, when we again drawing one straight line from P to Q, it will be like this, no? Same vector PQ. Right. So, here the displacement vector is the same, no? For both the cases. That means magnitude of displacement is either less or equal to the, that means actually the displacement of the object doesn't depend on the actual path taken by the object between the 2 positions. Okay, displacement of the object doesn't depend on the actual path taken by the object between the 2 positions. And the magnitude of displacement that you might have studied in 9th standard, the magnitude of displacement is either, or we have already discussed that in the, in the 3rd chapter, motion in a straight line. Right, the magnitude of displacement is either less or equal to the path length of an object between the 2 points. Alright, so in this video, it was actually a simple topic. We have discussed about the position vector and the displacement vector. I hope you got some ideas about this. Thank you.